Andhra Pradesh Public Service Commission 2012 Polytechnic Lecturer Electronics and Communication Engineering Question Paper Part 2. Given unit step response of a network is 1 minus e power minus at, then unit impulse response will be. So we know that impulse response is derivative of step response. Given function is 1 minus e power minus at. 1 minus e power minus at. So d by dt of 1 minus e power minus at. So d by dt of 1 is 0 and d by dt of e power minus at is minus of minus a e power minus at. So the answer is a e power minus at. So this is the impulse response. Here a is nothing but an alpha. So the answer is option 1. Next question. 1 megabyte is equivalent to, so we know that 1 byte is 8 bits, 1 kilobyte is 2 power 10 bytes, 1 megabyte is 2 power 20 bytes, 1 gigabyte is 2 power 30 bytes. So 1 mega is 2 power 20. Second option. Next question. The output of Boolean equation for full adder, sum and carry. So the definition of full adder is it is a combinational logic circuit with two inputs and produces the two outputs, sum and carry. Full subtractor is a combinational logic circuit with two inputs which produces the output, difference and borrow. So for full adder, the sum expression for sum is A XOR B XOR C. So in terms of min terms corresponding min terms are sigma 1, 2, 4 and 7. Next expression for carry in full adder is AB, BC, CA or AB plus C, A XOR B. So minterms corresponding to carry expression are sigma 3, 5, 6 and 7. So the correct option is 2. 1, 2, 4, 7 for sum, 3, 5, 6, 7 minterms for carry. So similarly for full subtractor, for difference, minterms are 1, 2, 4, 7, A XOR B XOR C, and for borrow 1, 2, 3, 7, A bar B, B C plus C A bar. Next question. The simplest difference in realization of half adder and full adder. So this is a half adder circuit, half subtractor circuit and half adder circuit. So half adder contains two inputs A and B and two outputs sum and carry. Similarly, half subtractor contains two inputs A and B and two outputs difference and borrow. So the half adder circuit has one XOR gate, one AND gate in addition to NOT gate, whereas half subtractor has only one XOR gate and only one AND gate. Only the difference between half subtractor and half adder is this NOT gate. The correct answer is 2. So option 2. Next question. Half adder is some important points are half adder is a combinational logic circuit with two inputs A and B and two outputs sum and carry. The expression for sum is A XOR B and expression for carry is AB. Half subtractor is a combinational logic circuit with two inputs AB and two outputs, that is difference and borrow. So expression for difference is A XOR B and expression for borrow is A bar B. Next question. Which of the following is also called rat race junction? So this image shows the rat race junction. It consists of four ports: port A, port B, port C and D. So port A and B are separated by a distance of lambda by 4. Similarly, port A and C are separated by a distance of lambda by 4. Port C and D are separated by a distance of lambda by 4. The distance between two ports, that is port B and port D, is 3 lambda by 4, which provides 270-degree between the signals. 270-degree phase between the signals. Next, this rat race junction is also called hybrid ring coupler. The mean circumference of this rat race junction is 1.5 lambda. This lambda by 4, 2 lambda by 4, 3 lambda by 4 plus 3 lambda by 4. That is 6 lambda by 4. Its circumference is 1.5 lambda. Case 1. If input signal is applied at port A, here input is applied, then equal amplitude in phase output signals are obtained at port B and port C. If input is applied at the port A, then equal amplitude same phase signals are obtained at port B and port C. Next case, if input signal is applied at port D, then two equal amplitude and out of phase signals are obtained. So input is applied at port D, then one signal is obtained at port C and one signal is obtained at port B, and port A is isolated port in this case. If input is applied at this point, two equal amplitude and opposite phase signals are obtained at port C and port B, whereas port A is isolated port. Next, third case. In case of power combiner, if input is applied at port B and port C, so input is applied at port B and port C. Then the sum of these two inputs is applied at port A, is obtained at port A, and difference input is output is obtained at port D. This is called power combiner. So this is the explanation for rat race junction. So which of the following is rat race means hybrid ring coupler is an answer. So next question. So in the continuation only. So what is E plane T means? The axis of side arm is parallel to electric field to the collinear arms. It is also called series T. Similarly, H plane T is also called shunt T. Then EH plane is all T is called magic T or hybrid coupler or 3 dB coupler. So this E plane is also called voltage junction or series junction. Next, the Boolean expression for the output XNOR logic gate for inputs A and B. So XOR logic gate is A XOR B, that is A bar B plus A B bar. XNOR is XOR gate plus NOT gate. So A XNOR B, A XNOR B. So the output is AB plus A bar B bar. So take option 1, AB bar plus AB. So this is XOR gate. Option 1 is XOR gate. So the option 1 is XOR gate. Similarly take option 2. So the output, the final expression of option 2 is AB plus A bar plus B bar, and for option 3 it is XNOR gate. So A bar B plus AB bar. So A bar, A bar, A bar B, B A, and B B bar. So A bar is 0 and B bar is 0, and the final we will get XNOR gate output. Similarly for option 4 the resultant is XOR gate. So in the question they have asked the output of XNOR gate. The resultant, the which of the following expression will give XNOR gate output? That is option 3. Next question. Three input signals. Sorry. The input and output signals of CE amplifier are. So in CE amplifier, common emitter amplifier, input signal and output signal are 180-degree out of phase. In case of common base and common configuration amplifiers, the phase difference between input signal and phase difference between output signal is 0. Only CE amplifier provides 180-degree phase shift between the input and output out of phase. Option 3. Next question. In a transistor alpha 0.98, alpha is a common base current gain of a transistor in, and beta is a common emitter current gain, gamma is a common collector current gain, common collector amplifier current gain. So what is current gain means? The ratio of output current to input current. So for common base alpha, for common emitter beta, for common collector gamma. Current gains, current gain means output ratio of output current to input current. Given alpha is 0.98 and emitter current is 2 milliamperes, and they asked to find the collector current. So alpha is given, we can calculate beta. The relation between current gain in common base configuration and current gain in common emitter configuration is beta is equal to alpha by 1 minus alpha. So from this substitute alpha value here 0.98 by 1 minus 0.98, so its value is 49. So current gain in common emitter configuration is 49, and the total current in a transistor is IE is equal to IC plus IB. So from this expression alpha, IC is equal to beta IB. So from this expression, total current is, so from this expression IC is equal to beta IB. IC is equal to beta IB plus IB. So that is beta plus 1 IB. So this is the total current. We know the beta value is 49. 49 plus 1 into base current. So given base current is not given, emitter current is 2 milliamperes. 2 into 10 power minus 3 by 50 will give the base current. And the base current value is 40 microampere. So base current is 40 microamperes. Next, collector current IC is beta IB. So IC is beta is 49 and 40 microampere. 49 into 40 10 power minus 6. Its value is 1.96 milliamperes. So emitter current is 2 milliamperes. So the collector current is very much not much smaller than emitter current. So the answer is option 3. Next, gain of an amplifier with feedback is given by relation. So this is a feedback amplifier network as shown in the image. Vs is the input signal, V0 is the output signal. The feedback signal is given to the feedback network of gain beta. So here feedback may be either positive feedback or negative feedback. So the gain of amplifier is with the gain of an amplifier with feedback, that is AF is A by 1 plus or minus A beta. The plus symbol is for negative feedback and minus symbol is for positive feedback. The gain of an amplifier with feedback. In the question, he did not mention whether it is positive feedback or negative feedback. So option A and option 4 are correct. Next question. So parallel adder. Parallel adder is an example for combinational logic circuit. It's a combinational logic circuits. Some other combinational logic circuits are multiplexer, demultiplexer, encoder, decoder, full adder, half adder, full subtractor, half subtractor. All these are examples for combinational logic circuits. Sequential logic circuits are flip-flops, latches, counters, shift registers. These are the examples for sequential logic circuits. So in the question, parallel adder is an example for combinational logic circuit, option 2. Next question. If x of t and its derivative are Laplace transformable, then Laplace transform of x of t is x of s, then limit t tends to 0 x of t is. In the question, he asked initial value theorem. Given Laplace transform of x of t is x of s, then as per initial value theorem, limit t tends to 0, f of t is f of 0. So that is limit s tends to infinity s into x of s. Similarly, final value theorem. So final value theorem is we need to calculate the final value at infinity. X of infinity is limit t tends to infinity x of t, that is limit s tends to 0 s into x of s. For this question, the correct answer is option 4. Next question. The open circuit impedance parameters independent variables are. So Z parameters are open circuit parameters is given by V1 is equal to Z11 I1, Z12 I2, and V2 is Z21 I1, Z22 I2. So this Z11, Z12, Z21 and Z22 are Z parameters are open circuit parameters. So this is current I1 and I2. This is equal to V1 and V2. This is a matrix representation. So in these open circuit parameters are Z parameters. The independent variables are current, and independent variables are current, input and output currents. So current at port 1 and current at port 2, whereas dependent variables are voltages at port 1 and voltage at port 2. So in the question they have asked independent variables. So that is option 4. If they ask dependent variables, then it is option 2. Next, channel capacity C of a band limited Gaussian channel equals to. So we know that channel capacity C as per Shannon-Hartley theorem is C is equal to B log to 1 plus C is equal to B log to 1 plus signal to noise ratio. So the correct option is 1. Next question. In M derived low pass filter has cutoff frequency here at 1000 Hz and M is equal to 0.6, then filter will have infinite attenuation at the frequency at M derived low pass filter have a infinite bandwidth is f infinity is equal to fc cutoff frequency square root of 1 by 1 minus m square, where f infinity is frequency of infinite attenuation. Given this critical frequency is 10 cube square root of 1 by 1 minus 0.6 whole square. On solving, its value is 1250 hertz. So frequency of infinite attenuation is 1250, the option 4. Next question, question 65. The electromagnetic transmission in a rectangular waveguide uses. So in a rectangular waveguide, so the transverse electromagnetic waves does not propagate in rectangular waveguides. So there is no existence of TEM waves. Next, so TE10, TE20, TE11, etc. All modes exist in waveguides except TE00. This TE00 mode doesn't exist. Among all these TE10, 20, 01, 02, TE11, among all these modes, TE10 is the lowest order mode for A greater than B. So lowest order mode means dominant mode. So dominant mode, the advantages of these dominant modes are it has lowest attenuation of all modes and it is the best propagation mode. So dominant mode means modes with lowest cutoff frequency or mode with highest cutoff wavelength. So which is the best one is TE10 mode. Next question. Power level of 10 dBm correspond to. So 1 dBm, so power in dBm is 10 log of power by 1 milliwatt. Power in dB micro is 10 log of P by 1 microwatt. In the question they have given power in dBm. So power in dBm is 10 log of P by 10 power minus 3. So 10 log of P minus 10 log of minus 3. So that is 10 log of P plus 30 dB. Given 10 dBm. So 10 dBm is, so 10 dBm, 10 log of 10 log base 10 power by 10 power minus 3. So its value is 10 power minus, so 10 power 1 into 10 power minus 3, that is power. So power P is 10 milliwatt. Option 4. Next question. The input to negative clamper has peak value of plus or minus Vp. Then the output at the positive and negative peaks are nearly. So the given question they have mentioned negative clamper. So negative clamper adds negative DC voltage. It is also called positive peak clamper. So for input plus or minus Vm, if it is added negative DC voltage of minus Vm, so then the output signal has peaks from 0 to minus 2 Vm. So 0 to minus 2 Vm. Option 1. Similarly, for positive peak clamper, it adds positive DC voltage, or it is also called clamp, negative peak clamper. So for positive clamper or negative p clamper, the output is from 0 to 2 vm. Next question. Modified ampere circuital law. So modified ampere law, so del cross h is equal to, so modified ampere circuital law, del cross h is equal to jc plus dou d bar by dt. What jc is conduction current density, jd is displacement current density. So the correct option is 1. So in phasor form, so this del cross h is represented, so this dou d bar by dou t, dou d bar by dou t, it is represented in phasor form as j omega epsilon e. So correct option is 1. Next question. If RH is a Hall coefficient, then conductivity is sigma, mobility is mu. All these three parameters are related as mobility mu is equal to 8 by 3 pi sigma RH. Approximately 8 by 3 pi is approximately equal to 1. So mobility is approximately equal to sigma RH. Mobility is approximately equal to sigma RH. Mu is equal to RH. So that is mu by sigma RH, or sigma RH by mu is constant. Correct option is 4. So mu by sigma RH, its value is constant, or sigma RH by mu is constant. Next question. The value of alpha in a transistor. Alpha is nothing but common base configuration current gain. Common base configuration current gain. So in common base configuration, so output current is collector current and input current is emitter current. So generally in a transistor, emitter current is greater than collector current greater than base current. So the relation is emitter current is collector current plus base current. So this base current is in microamperes, collector current is in milliamperes, and emitter current is in milliamperes. So there is only very minute difference between emitter current and collector current. So alpha is less than 1 and its value lies between 0.95 to 0.998. It is less than 1 but more than 0.9. So the correct option is 2. Next question. JFET. JFET is voltage controlled current source. So voltage controlled current source. Input voltage controls the output current. BJT is current controlled current source. Current controlled current source. Input current controls the output current. Operational amplifier is voltage controlled voltage source, VC VS. Input voltage controls the output voltage. So the correct option is 4. Voltage controlled device. JFET is a voltage controlled device. BJT is a current controlled device. 72 question. Compared to bipolar junction transistor, FET has. So this field effect transistor is a unipolar device, voltage controlled, and it is a voltage controlled device as seen in previous question. These FETs are less noisy, and BJT is a bipolar device, current control device, and noise is more. FET is smaller in size compared to BJT. FETs are thermally stable compared to BJT, small size, thermally more stable, smaller size compared to BJT, and field effect transistors are thermally more stable, and BJTs are faster, and the gain of BJT is, voltage gain of BJT is higher. Voltage gain for BJT is higher when compared to FET. Voltage gain is more here. So the leakage currents are less in FET. So input impedance, so ZA is very high in case of BJT. So leakage currents are relatively more in BJT. So input impedance is lower. So when compared to bipolar junction transistor, FET has high input impedance and low voltage gain. Correct option is 4. The voltage gain of BJT is much higher than FET and MOSFET because BJT has large trace conductance. BJTs are faster and cheaper than FETs. FETs are less noisy and does not suffer from minority carrier minority carrier storage effects compared to BJT. FET is thermally stable than BJT. FET is smaller in size compared to BJT. FET is a unipolar device, voltage control device, and leakage currents are negligible as well as less noisy. BJT is a bipolar device, current control device, noise is more. Next question. In the transfer characteristics of N-channel MOSFET, the region VGS greater than 0 correspond to. These are the transfer characteristics of N-channel MOSFET. So the transfer characteristics. So in these characteristics, if VGS greater than 0, it is in enhancement mode. If it is if VGS less than 0, it operates in this MOSFET operates in depletion mode. So the correct option is for VGS greater than 0, it operates in enhancement mode. If VGS less than 0, it operates in depletion mode. So the symbols for enhancement mode MOSFETs and symbols for depletion mode MOSFETs and characteristics are given. Next, the main advantage of using crystal oscillator is this crystal oscillator with a high quality factor produces oscillations of excellent amplitude stability and frequency stability. And this crystal oscillator is a fixed frequency oscillator. So the frequency of oscillations is fixed, and the main advantage of this oscillator is it gives constant frequency of oscillations. Constant frequency of oscillations is a main advantage and it is a fixed frequency oscillator. Correct option is 1. Constant frequency of oscillations. Next question. Kirchhoff laws are applicable to. So these Kirchhoff laws are applicable to all wave shape signals including AC and DC signals. Kirchhoff laws are independent of nature of elements, whether the element is linear element or non-linear element. Element is linear or non-linear. Element is active or passive. It is independent of nature of elements, whether the element is linear element or nonlinear element, active element or passive element. Kirchhoff laws are applicable only for lumped networks and not applicable for distributed networks. So example for distributed network is transmission line. For transmission line we cannot apply Kirchhoff laws, and Kirchhoff laws are applicable to all wave shape signals including AC as well as DC. So correct option is 4. For DC signals only, for AC sinusoidal waveforms only, wrong, and for AC and DC signals, wrong. So the correct option is 4. All wave shape signals. Next question. In case of surface wave, the frequency range of propagation is. So this surface wave propagation is also called ground wave propagation and the operating frequency range is up to 2 megahertz. The correct option is 1. So in other cases, skywave propagation or ionospheric wave propagation, for shortwave propagation, the frequency of operation is from 2 megahertz to 30 megahertz. For space wave propagation or line of sight propagation, the frequency of operating frequency range is more than 30 megahertz. In duct propagation or super refraction propagation, we are using ultra high frequencies or super high frequencies. In troposcatter propagation, ultra high frequencies are used. Next question. The lower cutoff frequency of n stage cascade amplifier is given as, if there are n stages in a, these stages are connected in a cascade manner, then lower cutoff frequency f suffix l of n is lower cutoff frequency divided by 2 power 1 by n minus 1, where fl is lower cutoff frequency of individual stage. Similarly, the higher cutoff frequency is given as fh of n is equal to fh of square root of 2 power 1 by n minus 1, where this fh is higher cutoff frequency of individual stage. Similarly, for the bandwidth, the correct option is 2. For lower cutoff frequency is f1 by 2 power 1 by n minus 1. Next question. Given electric field is E bar is equal to C1 e power minus beta minus j beta z y cap. In this expression, the electric field component is in positive y direction. The direction of electric field is positive y direction, and the wave is propagating in positive z direction. The propagation, so that is wave is propagating in positive z direction. So as per the correct option is 3. So now in the question, if they ask what is the direction of magnetic field, in this case we know that relation electric field component direction cross product of magnetic field component direction is equal to direction of propagation. So in this case, So AP is propagating in signal is propagating in positive z direction, and the electric field component is in y direction, and the magnetic field component is minus x direction. So magnetic field component direction h bar direction is minus x direction. Next question. Given a series RLC circuit excited by a voltage source of 200 volts and resistance 10 ohms, inductive reactance XL is 50 ohms. We need to calculate XC, capacitive reactance, and the frequency of operation is 100 Hz, and the current flowing through the circuit is 20 amperes. We know that relation voltage V is equal to current into impedance Z. So for series RLC circuit, the total impedance Z is resistance plus JXL plus JXC. So this J is nothing but a complex operator and its angle is 90 degrees, so that we can write this expression for voltage source is IR plus IXL 90 degrees plus IXC minus 90 degrees. The total impedance Z is equal to resistance plus JXL minus JXC. So it can also be written as resistance plus XL at an angle 90 degrees minus XC, sorry, plus XC at an angle minus 90 degrees. So if this impedance is multiplied with current, so Vs is equal to I into Z. So Z is R plus XL 90 degrees, inductive reactance 90 degrees plus capacitive reactance XC at an angle minus 90 degrees. So on calculation, so we know that formula A plus IB or A plus JB modulus of A plus JB is square root of A square plus B square. The same thing is applied in this expression Vs. So we know that magnitude of voltage source is 200 volts. So 200 square plus current square, that is 40 square, current is 20 square into R square, resistance is 10 ohms, 10 ohms plus XL minus XC. Inductive reactance is 50 minus XC whole square. So on calculations, the value of XC is 50 ohms. Capacitive reactance is 50 ohm. Option 4. Next question. Which of the following is not a reservoir used in standard Pascal? Record, repeat, packed. These are the reserved keywords of standard Pascal. This subroutine. The correct option is subroutine. Question 81. The characteristics impedance of Z0 for a lossless line is. We know that expression of expression for characteristic impedance of a transmission line is Z0 is equal to R plus j omega L by G plus j omega C, where R is resistance per unit length of the transmission line, G is the conductance per unit length of transmission line, and L is the inductance per unit length of the transmission line, and C is the capacitance per unit length of transmission line. Given the transmission line is lossless, for a lossless transmission line, resistance is 0 and the value of resistance per unit length is 0 and conductance per unit length is 0. So substitute these values in Z0. So Z0 is equal to R value is 0, j omega L by j omega C, square root of j omega L by j omega C. So its value is L by C. So for a lossless transmission line, characteristics impedance Z0 is equal to square root of inductance per unit length to inductance per unit capacitance per unit length, square root of L by C. It is not C by L. So correct option is 4. Next question. Long distance shortwave radio broadcasting uses. It uses ionospheric wave propagation. This ionospheric wave propagation or a skywave propagation are also called shortwave propagation. This long distance shortwave radio broadcasting uses ionospheric wave or shortwave propagation because in this skywave propagation the radio waves are radiated away from the earth surface. Question 83. If a square wave is applied to a differentiator, then output is. So differentiator is given, input is square wave, the corresponding output. If square wave is applied to a differentiator, the output is positive and negative spikes. Positive. Obviously, output is nothing but a spike signal with positive and negative peaks. So correct option is 1. So how to make this differentiate circuit is nothing but a RC high pass filter. So using RC high pass filter is a good differentiator if time constant of the circuit. So this time constant of the circuit is RC high pass filter time constant tau is nothing but RC. If the time constant of the circuit is tau is much smaller than time period of the input signal. So then this RC high pass filter acts as an excellent differentiator. So if an RC high pass filter acts as a good differentiator, if the time constant of circuit is very small in comparison with the time period for the input signal to make an appreciable change. This differentiator circuit converts square wave input to positive and negative spikes. Next question. What is the capacity of channel? So this channel capacity is defined as maximum rate that the channel is capable of transmitting without errors. So correct option is 3. So channel capacity C as per Shannon-Hartley theorem is C is equal to bandwidth log base to 1 plus signal to noise ratio. This channel capacity is directly proportional to channel bandwidth. So channel capacity is directly proportional to channel bandwidth. Next question. Which of the following is taken as reference antenna for directive gain? So generally, this isotropic antenna is taken as a reference antenna in calculating the directive gain of other antennas. Why? Because this isotropic radiator is a fictitious radiator which radiates energy uniformly in all directions. It is a fictitious radiator, imaginary antenna which radiates energy uniformly in all directions, and it is a lossless hypothetical antenna. The gain and directive gain of this isotropic radiator is unity. This isotropic radiator is a lossless hypothetical antenna with which all practical radiators are compared. Hence, it is used as a standard reference antenna for directive gain or simply gain measurements. The gain and directive gain of this isotropic radiator is 1 or 0 dB. Practically, isotropic antenna does not exist. Next question. Which of the following configuration can be used as a constant current source? So obviously it is common base configuration. Some more points related to common base configuration is input resistance is very low, output resistance for common base configuration is high, current gain is less than unity, and voltage gain is high, which is comparable to that of common emitter configuration. Next, inclusion of resistance in emitter circuit. So when we include a resistor in the emitter circuit, so it obviously the thermal stability of circuit increases if emitter resistance is included. Improves thermal stability. Option 4. Next question. Reflex klystron. So reflex klystron is a single cavity resonator. So reflex klystron is a single cavity single cavity variable frequency single cavity variable frequency microwave oscillator. So it generates microwaves of low power and low efficiency. The output power of reflex klystron is low and the efficiency of reflex klystron is also low. So reflex klystron is a single cavity variable frequency microwave oscillator or microwave generator of low power and low efficiency. Correct option is 1. Question 89. In Pascal, x power y is evaluated as none of those, because in C language x to the power y is given by this instruction p is equal to power of x comma y. In Fortran, x power y is evaluated as x star star y. But in case of Pascal, does not provide the operation of exponentiation, that is, the operation of raising an positive number to any power. but this operation is evaluated by using, in this Pascal does not provide exponentiation operation. We cannot perform this x to the power y operation in Pascal. But how to evaluate this exponential operation is by using, but this operation is evaluated by using exponential and natural logarithm functions simultaneously. So that is exponential of b star ln of a. It is nothing but a power b. So a raised to the power b. In this way, we can execute the operation in Pascal. But directly we cannot perform x raised to the power y in Pascal. So correct option is 4. Next question 90. The Laplace transform of unit ramp function starting at t is equal to a is. So this is unit ramp function. So this is ramp function. R of t is t for t greater than 0. Its value is 0 for t less than 0. So it is shifted by, the ramp signal is delayed by a second. So the signal starts from here. So this is time axis. So signal starts at t is equal to a, and this is origin. So magnitude axis x, y. This is time axis. And the mathematical representation of this signal is r of t is equal to t minus a for t greater than 0, greater than or equal to a, and it is 0 for t less than a. So we know that Laplace transform of ramp signal t is 1 by s square. So Laplace transform of t minus t naught, signal shifted by t naught second time duration. Laplace transform of t minus t naught is e power minus st naught by s square. So therefore Laplace transform of a signal t minus a shifted by duration a second is e power minus sa by s square. The correct option is 3. Next question. So given 23.625 base 10 in decimal number is given, and they ask to convert in to octal number. In conversion of decimal number to any radix number representation, successive division is for integer part. For integer part, successive division for integer part. So that is 23 divided by 8. So its value is, here quotient is 2, quotient is 2, remainder is 7, and its value is 27. 27. Next, for uh, fractional part, successive multiplication, that is 0.625 into 8. So its value is 5.00. Hence 23.625 base 10 is equal to 27.5 base 8. So integer part is successive division and fractional part is successive multiplication. For integer part, quotient is 2, remainder is 7. For fractional part, its value is 50,000 here. Next, hence the conversion value is 27.5. The correct option is 2. Next question. Light will be produced in LED is because of. So LED, the light will be produced because of spontaneous emission. Because of this spontaneous emission, light is produced in an LED. So what is this spontaneous emission means? So generally LED works on the principle of electroluminescence. So in LED, two types of recombination takes place. Generally electrons and holes recombine at the junction when it is forward biased. When LED is forward biased, electrons and holes move towards the junction and then recombination takes place. The transition of electron from higher energy level to lower energy level causes emission of light, that is spontaneous emission. when electrons and holes move towards the junction. So electron is coming from higher energy state to lower energy state. In that case, light is emitted. In LED, two types of recombination takes place. One is radiative recombinations and non-radiative recombinations. The output of this radiative recombination is light, and the output of this non-radiative recombinations is heat. If the efficiency of LED is 100%, it means all the recombinations, electron hole recombinations at the junction is of radiative type. Next question. The gain bandwidth product of amplifier after inclusion of negative feedback. Because of this negative feedback in an amplifier, gain increases by 1 plus a beta times, and bandwidth sorry gain decreases by 1 plus a beta times, and bandwidth increases by 1 plus a beta times. Now the gain bandwidth product before feedback as well as after feedback remains constant. There is no change in bandwidth product, but gain decreases with negative feedback and bandwidth increases with negative feedback, but their product remains same. Option 3. Next question. So waveguide. So waveguide is acts like a high pass filter. Waveguide acts like a high pass filter. Only the frequencies greater than cutoff frequency are propagated, and the cutoff frequency of this high pass filter is Fc is equal to 1 by 2 pi square root of mu epsilon square root of m pi by a whole square plus n pi by b whole square, where a is a wider dimension of waveguide in centimeters and b is a wider dimension of waveguide in centimeters, and m and n are number of half cycle variations across wider directions dimension, and n is number of half cycle variations across narrow dimension. So waveguide is considered as a high pass filter. Option 1. Next question. The Cassegrain feed is used with the parabolic reflector to increase the beam width of the system, to increase the gain of the system, to allow the feed to be replaced in a convenient point, and to reduce the size of main reflector. The correct option is 3. So this is a Cassegrain antenna here. It is an improved feed system for a rectangular antenna. It consists of two reflectors, that is and uh, primary reflector, which is a paraboloid itself, and secondary reflector, which is a small hyperboloid. This primary reflector is a paraboloid and secondary reflector is a small hyperboloid. Located on this hyperbolic reflector is located at a point where the focus of both primary reflectors and secondary reflector coincides. This primary feed radiator. So horn antenna is a primary feed radiator is placed around the opening near to the vertex of a paraboloid on the axis of parabola and hyperbola. The rays coming from this primary horn radiator gets reflected to the hyperbolic surface. From here the rays gets reflected to the hyperbolic surface. From hyperbola surface to gates gets reflected from hyperbola surface onto the parabolic reflector, and finally planar wavefront is produced. The Cassegrain feed is used with a parabolic reflector to allow the feed to be placed in a convenient point. And the disadvantage of this Cassegrain feed is that some of the radiation from this main reflector is blocked by this hyperbolic reflector. So the correct option is 3. Next question. So this is the Cassegrain feed system is given here. Primary feed radiator is horn antenna, and then parabolic reflector is given, hyperbolic reflector is given, and this hyperbolic reflector is placed at a point where the focus of this primary reflector and secondary reflector coincides. The disadvantage is some of the radiation coming from this parabolic reflector is blocked by this secondary antenna, that is hyperbolic reflector. Next question. For a fixed bias circuit, stability factor S is. So for a fixed bias circuit, stability factor S is 1 plus beta, where 1 plus beta, where beta is a DC current gain. The correct option is 4. Next question. The most commonly used BJT amplifier circuit is, so voltage divider bias, self bias, or emitter bias. So let us see the circuit diagram of voltage divider bias. Supply voltage VCC is given, collector resistor. This is NPN transistor, because the arrow is facing towards away from the base. It is an NPN transistor, and the emitter is connected to ground, common emitter NPN transistor. So these resistances are R1 and R2. So base input signal is applied at V input, and output is collected across a collector V output. This is collector, base, emitter. So common emitter NPN transistor, and the equivalent resistance RTH is R1 R2 by R1 plus R2. So this equivalent circuit we can draw like this. This is resistor RC, voltage source VCC, output V0, input V in, and this resistance is RTH. This is base, collector, emitter. Arrow is away from the base. It is an NPN transistor. This emitter resistor is connected to ground. And the voltage source VTH. No, it is VTH. So this is the equivalent circuit for this. And VTH is base VB into R2 by total resistance at the input R1 plus R2. This voltage divider bias or self bias or emitter bias is most preferred bias circuits, because for the reasonable values of R1, R2 and RE, the stability factor is less, the stability factor of less than 10 can be achieved, because least stability factor is more desirable. The correct option is 2. Voltage divider bias, emitter bias or self bias. Next question. Which of the following is not a traveling wave? So E is equal to Em sine beta x, and it is an standing wave. Rest all the three are traveling waves. So take option 1, E is equal, so take option 2, E is equal to Em cos omega t minus beta x minus omega t. So beta x minus omega t is nothing but cos of minus x is cos x, cos of omega t minus beta x. So the wave is propagating in positive x direction. The wave is propagating in positive x direction. So similarly, take option 1, E is equal to Em sine beta x minus omega t. Sine of minus x is minus sine x. So the wave is propagating in negative x direction. On third option, E is equal to Em sine omega t minus beta x. So wave is propagating here in positive x direction. Wave is propagating here positive x. Here it is minus negative x direction. Here the wave is propagating in positive x direction for option 2. So therefore option 4, it is not a traveling wave, it is a standing wave. Next, the major advantage of traveling wave tube over klystron lies in it. So obviously it is higher bandwidth, because traveling wave tube is a broadband device, and this klystron is a narrowband device. So klystron has cavities and TWT has no cavities in it. Traveling wave tubes are broadband devices with no cavity resonators, and this TWT, traveling wave tube, make use of distributed interaction between electron beam and RF field over the full length of the tube, whereas klystron are narrowband devices which use of cavity resonators to velocity modulate the electron beam over narrow gap. So therefore, this traveling wave tube is a broadband device, so higher bandwidth. Which of the following is a not a proper formula translation expression fortran. So all the mathematical operators followed in fortran. The symbols of mathematical operations are addition, plus, minus, subtraction, asterisk for multiplication, slash for division, and exponential is double asterisk. It is having highest priority. So some rules of arithmetic operators are: more than one arithmetic operator should not be allowed successively. Suppose 2 plus star 3. So addition operation and multiplication operation successively we cannot allow, Proton cannot allow successively two operators at a time. And every arithmetic operation must be explicitly given by its symbol. In evaluating this any expression by using Fortran, exponential has highest priority, and then multiplication and division are evaluated from left to right, and finally addition and subtraction are performed. So in this question, so a star star b 2. So the answer is 3. So take option 1. So first a by c is evaluated. So this a by c is evaluated, then addition with b, and finally result so far is subtracted from D. So option 1 is proper Fortran expression. Next option 2, a plus c divided by b plus d. Initially parentheses are a plus c is evaluated and b plus d is evaluated, and finally perform division. So next b plus star a divided by c. This is invalid Fortran expression. Option 3 is invalid Fortran expression because addition and multiplication are simultaneously there. You just see this rule 1, more than one arithmetic operator. Rule 1, more than one arithmetic operator should not be used successively. So the rule 1 is violating by this option 3. Next option 4, initially parenthesis is evaluated and then double exponential operation is performed. So correct option is 1.